This is 1.7 right triangle applications. You do need your calculator for this lesson, so make sure you have that available. It says round lengths to the nearest thousands, and we're going to be rounding our angle to the nearest degree. It says a ship passing a lighthouse at its closest point to the lighthouse, the radar determines the ship is 2,400 meters from the lighthouse. All right, let's check out these mad drawing skills. So here's my lighthouse. Lighthouse. And then the ship at its closest point is 2,400 meters. The ship continues on its path, and the next measurement is 2,600 feet or 15 meters. Okay, so my ship is going to continue on its path, and still measuring to the lighthouse, I have 2,650 meters. Okay, so I have drawn a right triangle, of course. All right, A says, by what angle did the ship's bearing from the lighthouse, here is the big one, from the lighthouse change? So I'm going to go from the lighthouse and put a theta. So from this, how did the bearing change? Okay, or I basically want to know this angle. So for A, my pen is going crazy. From A, I want to know how my bearing changed. So I can use my adjacent and my hypotenuse, so that would be cosine of theta. And that would be 2,400 over 2,650. And because I'm looking for theta, you should know that I can just rewrite from our previous notes, and that's going to change to an arc cosine of 2,400 over 2,650. Now remember, your calculator needs to be in degrees in order to figure this answer out. And I got 25 degrees, rounded to a whole number. All right, for B, it says, how far did the ship travel between the two measurements? So it looks like we're looking for this area right here. You could do Pythagorean theorem, which is 2,650. Minus the 2,400 and get your unknown, and I get about 1,123 rounded meters. If you use trig, you are going to get a slightly different answer. In fact, I would use tangent. Using tangent from that angle, that's going to be tangent of 25 degrees. And the reason you get that is because, well, you should not get a different answer. I'm sorry. You should not get a different answer because you're not going to use 25 degrees. You're going to use this answer, which is non-rounded. You never use the rounded answer until the very end. So this would be what? X over 2,400. If you use the rounded answer, of course you will get a different answer. You should get the same answer, which is 1123. And that would be meters. All right, let's look at the next one. A person on the edge of a canal observes a lamppost on the other side. So here's my small person, and here is the lamppost, with an elevation of 12 degrees to the top of the lamppost. So remember, elevation is out and then up. and then depression is out and then down. Okay, to the bottom of the lamppost. The person's eye level is 152 centimeters, so the person is 152 centimeters tall. Find the width of the canal. So we want to know how long this is right here. This is our unknown that we're looking for. Okay, what I'm going to do is break these two triangles apart. So for A, if I want to know the width of the canal, I know how tall the person is. I think I'm going to use the depression triangle. So I'm going to redraw that. Okay, so I don't know this width right here, the length of the canal. I do know it's 7 degrees, and I know how tall the person is. I'm just kind of moving some information over. Okay, and I can use tangent, because that's opposite over adjacent. So this would be tangent of 7 degrees is opposite 152 over adjacent. If you solve for x, that's going to give you a rounded answer of 1,237.941. And that should be the length of the canal. That would be centimeters. Okay, so now I know the length of the canal. I can find B. I'm going to use my information. It says find the height of the lamppost. All right. So I don't know how high this is, but I do know this right here is 152. But I don't know this one. Okay? The nice thing about this is I can use my top triangle now. This is 12. I don't know x, but I do know this bottom one, which I just found, was this number right here. And it's still in my calculator, which is the nice thing about it. Okay? And I can use tangent again. I like to use tangent because it's easy. So I'm going to say tangent of my 12 degrees is opposite, which is my x value, over the one that I just found, which is this 123.7, which is already in my calculator. Remember, you don't round until the very, very end. So this is my stored value in my calculator. So 1,237.941. And when you solve that value, the second part of my lamp is going to be 263.132. And then, of course, I have to add the height of the person, which is the bottom part of the lamp, which is 152. And I get a total lamp height of 415.132 centimeters. Perfect. Okay, a swimming pool is 3 feet deep in the shallow end. The bottom of the pool has a steady downward drop of 12 degrees towards the deep end. If the pool is 50 feet long, how deep is the deep end? Okay, there's a couple of ways I do this, and I draw it kind of strangely. If we know the shallow end is 3 feet, I kind of draw this as a rectangle at first. We know this is 3 feet, right? Then it drops off to the deep end, and I know it doesn't go straight off there. That drops off as a 12-degree drop off. This is the deep end, right? We know it's 50 feet long, and I drew this as a rectangle because I know that it's 50 feet long, right? And I could have put 50 up here as well. Why I broke this up is because I see this as a triangle as the deep end. Okay, it says how long is the deep? Well, this is why I did this, because this is the deep end. All right, I already know the shallow is 3, it's 50 feet long, so let's find the deep end. So I can use this as a tangent again. I can go opposite over adjacent. So tangent of 12 degrees is opposite over adjacent. And if you solve, you should get the 10.628. Now, I know this right here is 10.628, but realistically, we need to add this as well, because I know the shallow is just 3, but doesn't the D go all of this? So I'm going to add, my pen's jumping. Stop. There we go. I'm going to add back in my 3 feet to get a total of the deep end of being 13.628 feet. All right, number 4 says, Penny stands 12 feet from a statue. The angle of elevation from eye level to the top of the statue is 30 degrees. Okay, let's see what we can do here. Here is my statue. I'm going to make it very obvious. Here is Penny. It says the angle of elevation from eye level to the top is 30. Remember, you always go out and then you look up, and that's elevation. That's 30 degrees. The angle of depression is 15. So out and down is 15. Okay, don't forget horizontal component, which we did. How tall is the statue? It says she stands 12 feet from it. So this is 12 feet. All right, so we just need to know how tall. So I'm going to break these two triangles apart. I'm going to do the top triangle first and find X value. This is 30 and this is 12. So we need to do opposite over adjacent. Oh, tangent once again. Tangent of 30 degrees is opposite over adjacent. And that looks like X is going to be 6.928. Looks like we're in feet. And now I'm going to do the bottom one. And I'm going to call that Y. This is still 12. This angle depression is 15. I still can use tangent of 15 degrees. And that is Y over 12. Looks like Y turns out to be 3.215. And if I put these two together, my total statue is 10.144 total feet. And my last problem. A 60-foot drawbridge is 24 feet above the water level when it is closed or down. When open, the bridge makes a 30 degrees angle with the horizon. So here's my 33 degrees, and it looks like this is going to be 24. Okay, 33 degrees with this. Okay, how high is tip P when the bridge is open? So we want to find that right there. That's X. And this is a 60-foot bridge. So it looks like I have some information to work with. So how about for A, we draw a triangle here. If this is P, this is 33 degrees, and this is 60, we need to find this information. Huh. Okay. How about opposite and a hypotenuse? It looks like we're going to use sine for this one. So sine of 33 is going to be opposite over hypotenuse. That's going to give you a value of 32.678. Okay. Well, it says P above the water. Well, P is up here, and above the water, let's see, 24 is only, I lied about that. 24 is only this right here. Oh, wait. 24 feet above the water level when it is closed. So, really, that's not 24. This is 24. So, we need to add 24. So P is really a total of 56.678 feet above the water. That sounds right. Okay, now let's look at B. It says, when the bridge is open, what is the distance from P to Q? So we need to find this distance right here, P to Q. All right, I bet I can use a triangle on this one as well. Okay, from P to Q, how about I find, you know what, I'm going to find this distance right here. And there is a reason why. Remember, when the bridge is opened or closed, this is 60. Okay? If I find this distance, only this right here, I can subtract 60 minus this distance, and I will know this. Does that make sense? Okay, so I'm going to draw this triangle once again. Still with 60. Still with 33. Except I'm going to find this bottom part. Okay, so that looks like I'm going to have to use cosine of 33, and that's going to be adjacent, which is y over 60. So that gives me y is going to be 50.320. That's 320. Okay, that is the distance from the origin here to this. So this area right here. So if this is 50 and the whole thing is 60, let's subtract the two. So I'm going to say 60 minus the 50. My pen is just not working today. 320. And I should get the distance from P to Q. And it should be 9.68. From P to Q. All right. If you have any questions, please bring them to class.